Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy, and today we are continuing our trigonometry series by looking at a complex question that incorporates several of the recent concepts that we've been looking at in this particular video series. So let's get straight started. This video is aimed at students in grades 10 and above, so it's not really appropriate for juniors. It is a bit too complex. Okay, we're going to read this question in three parts. Captain Blacktooth has found part of a treasure map at point A. Now, the picture of the map here is purely for illustrative purposes. You can see there's no point A on there. We're actually going to have to draw the map ourselves. Another part of the map is buried 450 metres from point A on a bearing of 72 degrees true, and that's point B. Another part of the map is buried 885 metres on a bearing of south 75 degrees east from point A, and that's point C. So what we need to do, the poor captain has to travel from A to B to C and collect all those parts of the treasure map so that he can then search the entire area in between. So we need to calculate that initial distance he has to travel to collect the parts A to B to C. And then we need to calculate the size of the area he needs to search. So there's a few parts to this particular question. Let's focus just on this first part here, and I've highlighted a sentence in orange. This is our starting point, the information about point A. So point A is our origin. We're going to draw a diagram. It's always good to start with some compass points, and we're going to label point A at the origin of that compass points. And then from there, we're looking out from point A on a bearing of 72 degrees true to point B. So it's roughly in that first quadrant somewhere, probably a little bit more towards the east line, but for illustrative purposes, that will be fine. Now, we're going to look here, that's that angle from north. Remember, we read true bearings from north, clockwise direction, around to the line that points to our particular destination. So that's 72 degrees that passes through there. And that's 450 metres that he's travelled to get to point B. Now, our next part we're going to focus on is also highlighted in orange now. This is the next part. It's point C that we need to find. And from point A, he's got a bearing of south 75 degrees east. So we're no longer looking at true bearings, we're looking at compass bearings, which means we need to firstly label the rest of our compass points. And in this situation, with these types of bearings, we start at the south and move towards the east by 75 degrees. So that's our next line there. And I've drawn that because the distances are approximately almost double. So I've drawn the line of C a little bit longer, but once again, that angle there of 75 degrees is probably more towards the east line, but I wanted to make sure the picture was actually legible, what you could see. So now we've got our points A, B, and C drawn in, and we've got our distances drawn in. We now need to add our remaining line here, and before we do that, we want to think about that angle that's in between, because ABC is going to form a triangle, a non-right angle triangle. So we know our north-south line is a straight line, and it makes up 180 degrees. We've got two parts of that, 72 degrees and 75 degrees. So the difference between those will give us that angle in between, angle BAC. So that's going to be 33 degrees, and that'll be inside where we're going to be drawing our triangle. So now we've got our non-right angle triangle, we've got an angle inside the triangle, and we've got two sides of the triangle. So now we need to think about what we're doing. We're actually trying to work out the distance from A to B and then on to C. Now, if you would remember, we don't have BC. We need to find the distance of BC. And so that's the part we need to work out now. What is that actual distance of BC? How will we get that information? Well, we're going to remove all of the compass now, just so we've got our triangle. And then we need to think about the different strategies that we've come up with over time. So we've come up with the sine rule. Well, with the sine rule, we could actually use this triangle. We could work out all the other angles in the triangle. Would that be particularly helpful? No, because we're not trying to find angles. We're trying to find this unknown side. What we could do, though, is if we found all those other angles in the triangle, because we could find, using the sine rule, the angle of BAC at the bottom of the triangle, and then we could use the two angles we've got, to find the difference of 180 degrees. That would then help us to find the other angle of ABC, and then once we've got all the angles, then we could use the sine rule again to find the missing side. So we'd have to apply the sine rule a couple of times. There is an easier way. We can use the cosine rule. If you remember, the cosine rule is all about when you've got an angle in between two sides, then that angle there helps us find the opposite side of that triangle. So we're actually going to be able to find BC using the cosine rule. So rather than applying the sine rule a couple of times, it's quicker just to go straight to the rule that's the most helpful. So we're going to start by writing the rule. Now you may have seen this on your formula sheet as c squared equals a squared plus b squared minus 2ab cosine of c. But the reason why I've got the letters differently, if you remember, the subject of this equation is the side that we're trying to find. We're trying to find this side over here, BC, and it's opposite A. So if we were to label our triangle with the little letters, this would be little side A over here, little side B, little side C. Now typically in the cosine rule you'll see c squared is the subject of your equation. However, it's important to remember with the cosine rule, the subject of the equation is the side you're trying to find, and in this case we're going to use little a because that's the variable that applies. So I've just changed the variables in the formula, and that's okay because it means I'm going to find the correct side and use the right part for that. Okay, so now a squared is still the subject of my equation. That's the side I'm trying to find. I've got the two sides on either side of the angle in the middle, and I've substituted into the equation all of the important information. I'm going to work that out in small parts. You could actually just put the whole thing on your calculator, but sometimes there's marks awarded in between, so it's a good idea to show you steps of working. So I've evaluated the squareds. I've also evaluated the 2 times 450 times 885 on my calculator. And now I'm bringing that information. What this time I've done is I've added these two numbers together, and I've found this part here. Now the reason why I'm also doing this in small steps is to show you the order of operations of what you're doing on the calculator. We start up here and we square the numbers first, and then we leave this part here till we sort of get to this stage rather than having to work with cosine 33 as a number with lots of decimal places. Then we get to this start point here, we take the square root of that, and we've found A is equal to 563.67 metres. Okay, now we've now got the two sides that Captain travels, and well, we need to remember that we're not travelling all the way back to A. We only need to travel A to B, B to C. That's what the question asked us to do. So be careful you don't add all three sides together. You only want to add the two sides together, and you're going to get Captain Blacktooth's distance to collect the maps will be 1013.67 metres. You may even want to round that up to the nearest metre, 1014 metres, or it's 1.014 kilometres. Okay, so now we've found the distance to travel to collect the parts. We've now need to find the area that he's going to search, because he's going to search all in this area in here. We've got two rules that we could use to find the area. Half AB sine C, we did a video on that a couple of videos ago, and our last video was Heron's rule. Now we need to think about what's the most practical rule to use. Either rule is going to work, because Heron's rule only needs three sides, we've got that, and this first area rule with the sine part of it only needs an angle with sides on either side, so we've got that as well. So you need to ask yourself, what is the most efficient way to find the answer? Both rules work. One is quicker. The half AB sine C is definitely faster, because with Heron's rule we've got to find S first, and then we've got to use that big formula with the square roots. There's a lot more steps of working. Our first formula is the most practical one to use, so we're going to jump in and use that one first. Always write your formula. You'll notice that this time as well, I've changed the variables from AB sine C to BC sine A, and that's to match the diagram that I've got. That's always a good idea, so that you don't put the wrong letters in the wrong places. And we're going to evaluate that now using our calculator and take a few small steps, and we find that he's going to be searching a big area, 108,451 square meters, and we should write that as a statement as well. So we've now solved the problem, which is fantastic. Now I've got a quick pirate joke for you. You could tell me in the comments one of your favourite pirate jokes, as long as they're clean. What is a pirate's favourite strand of mathematics? It's arithmetic. Well, that was really bad and probably will embarrass the heck out of my children, but who cares? That's what mum's jobs are for. Well, did you find this video helpful? Did you like my pirate joke? If so, like, subscribe and hit the bell. Tell us in the comments, or share the video with a friend or a teacher. Share it on your socials page if this was something that was useful to you, combining those different concepts together to consolidate your knowledge of bearings and trigonometry. And if you've got questions about what you saw today, you can contact me at mcclutchymass@yahoo.com. There's no AU on the end of that. And we've also got the facility for you to direct message us on Facebook or Instagram, whatever is most convenient to you. So if you've got questions, the best place is to ask us there. We can provide you with a detailed answer. Not really good putting questions in the comments. It's kind of hard to explain it in a short space with a limited number of characters. Well, if you've got any comments, questions, we'd love to hear from you. Please like and subscribe to the channel. Thank you so much for watching. Our next video coming up is strictly for our senior advanced students that are studying moving on into calculus. We're looking at the unit circle. Well, I'm Natalie McClutchy. You've been watching McClutchy Maths. Have a wonderful day.